All right, today we are going to talk about dividing fractions. And there are two main ways when we divide fractions that we can solve these problems. There is a method that uses a common denominator, and when we do that, we can get rid of the denominator and just divide our numerators. Or we can multiply the first fraction by the reciprocal of the second. So I'm going to take, and I'll come back up here in a second, but I'm going to take and put some fraction problems on the board. Okay, so let's take a look at these. Okay, so I've zoomed in a little bit, and our first way would be to find a common denominator. So I'm going to take a look at number 1 here. And I'm going to go with a common denominator method. So first thing I'm going to do is write the problem 1/3 divided by 9. If I had to share 1/3 of an object with 9 different people, this would be the problem that represents that. So the first thing we need to do with a common denominator is to turn both fractions into, or turn both numbers into fractions with a common denominator. So step 1 would be to rewrite 9 as a fraction over 1. That way we can change it into a fraction that is a common denominator of 3. Okay, so 3 is our common denominator, and 9 becomes a 27 in that case. The next step would be to forget about the denominators now, and we're only worried about the division of the numerators. So this gives us 1 divided by 27. Now, in this, my first number, the 1, is my numerator of my answer. So that'd be 1 and then divided by 27. So 1/3 divided by 9 is going to equal 1/27. All right, so let's try another one. Let's try the second problem. Let's skip the second problem. Let's go on to problem number 3. Okay, I'm going to do problem number 3 using that same algorithm. Okay, and problem number 3 is 5/6 divided by 1/12. Okay, and again, we're turning these into common denominators. So as I look at this, I see 6 and 12. 12 is a multiple of 6, so my common denominator should be a 12. So 12, we'll leave 1 there. 5/6 would become 10/12. Okay, so this actually means that I have a 10 divided by 1 because my denominators fall off. And the reason why they fall off is because they're referring to the same number of parts now, and so I no longer need to consider them in my calculations. So 10/12, I'm just going to go ahead and rewrite them though. Okay, the 1 is my denominator, the 10. So the first number, the 10, becomes my numerator. The second number, or the 1, becomes my denominator in my answer, and then I have 10 over 1, which equals 10. So if I had 5/6 of an object and I cut it into 12ths, 1/12 of that, I would have 10/12ths of that. All right, not 10/12ths, but 10 pieces that are each 1/12. All right, so let's take a look at the second algorithm. In the second algorithm, I am going to start with problem number 2. So we're going to start off by writing 12 divided by 1/6. So 12. Now my pen's not working, so hold on just a minute. Okay, pen problem saved. I know that would make like a little jump. So, all right, so we're going to start off by writing it. The second algorithm is showing you how to multiply by the reciprocal. Now, the reason why we do this is because we've talked about fractions being nothing more than division problems. So this is really saying 12 divided by 1 divided by 1 divided by 6. So as a fraction, that would equal 12 over 1 over 1 over 6, or 12 firsts divided by 1/6. Well, I don't really like that in my problem, so I'm going to get rid of this 1/6 by turning it into a 1, because anytime I have a fraction that I can turn into, have a denominator of 1, then that then I can leave off the denominator. Like for 12, it's really 12 over 1, but we leave off the 1 because 12 first is just kind of funny. So it's just 12 whole numbers. All right, so I can do that by multiplying by the reciprocal. So the reciprocal would be 6 over 1. So 1 times 6 equals 6. 6 times 1 equals 6, and that equals 1. So my denominator is now 1. But because I multiplied the denominator of this part by a reciprocal, I also have to multiply the numerator by the reciprocal. So that would give me 12 times 6, which would be 72. And then 1 times 1, which would be 1. And then 72 over 1 would simply be 72. So this is why. So this is a lot of work, and it looks really confusing. But essentially what we're doing here is all we're doing is multiplying by the reciprocal of the second fraction. So let's take a look at number 4. Number 4 says 5 divided by 1 1/2. So the first step would be to turn whole numbers into fractions over 1, and then mixed numbers into improper. So 1 1/2 would be 3/2. Now, I'm going to keep my first fraction alone. I'm going to leave it alone, and I am now going to flip or use the reciprocal of the second. So the reciprocal here would be 2/3. So we're going to multiply by the reciprocal of the second fraction. So now we have 5 times 2, which is 10, 1 times 3, which is 3, and then 10/3 would equal 3 1/3. All right, so before coming to class tomorrow, I would like for you to finish problem 5 and 6 before class, and then for problem 5, try the common denominator strategy. For problem 6, try the reciprocal strategy. All right, and I'm going to go ahead and scroll back up here and zoom out of the page a little bit. That way you guys can see both algorithms. Okay, this algorithm would be the common denominator algorithm, and this one over here, starting with step 3, is the multiplication of the reciprocal. All right, so go ahead and get these into your spiral practice. Maybe do a few more than 5 and 6. You can go ahead and try 7, 8, 9, 10, 11, and 12. It's entirely up to you. But those are the two main strategies we have for for dividing fractions and rational numbers. All right, let me know if you have any questions. See you in class.